Okay, so guys, welcome back to my YouTube channel. So, as we were checking about BigQuery, so first we are going to explore the weather data. For weather data in any BigQuery, what you have to simply do is you have to go and in this you have to select BigQuery. You will see this field appears. I was preparing for this. We can see this Explorer. In Explorer, we can pin existing projects, we can enter a project name, we can explore public datasets. So as of now, I need to explore the public datasets, and there are, as you can see, there are lots of public datasets here. I am going to explore NOAA GSOD. Okay, NOAA stands for National Oceanic and Atmospheric Administration. Okay, so this because since we are going to explore the weather data, we need to see this. And this is the global data. So this we can view the data set. We can see the samples. Like these were the sample queries. What was the warmest day? Which stations receive the most snow days? Like we can explore the data. We can study the data. So I'm going to view data sets. As we can see, this opened in a new tab. Hmm. Okay, so this opened in a new tab, and here you can see these are the pinned projects. So I am going to add another project into this. So project name should be BigQuery Public Data. So I've entered this BigQuery Public Data, and I somehow want to add this NOAA GSOR. Uh, so as we can see, complete range of hosts, Austin, BigQuery public data. I think this is not the right one. Let's try to add another data. So I can also search for project. Let's see what projects I have. So I have this project which is already pinned. Hmm, let me add a data. I'm trying to explore public. We just did this. We explored the public data sets, and again I'm searching for NOAA GSOD. NOAA is National Oceanic and Atmospheric Administration. I'm just viewing this data set again. After viewing this data set, I'm going to add this data set to my Explorer. So let's see how I can do this. I think here is this, you know, let me copy the data set ID, and I'm entering a project name. I have entered the data ID. How to. So as we can see the document, this we have to go to activate. We have to enable the BigQuery API. This public data set applications. Mm, so basically, we're trying to make changes to this one for mm, for making changes. G sword. BigQuery. Okay, let me add again BigQuery. Okay, so what I did before, I will do again. BigQuery public data. Okay, I pinned it again. So I think we did this last time also. So after public data, I have to search for no sorry GFGHIJKLM GitHub GIJ Noah. I think yeah we are close. So this is the data. We got the data successfully. Now we can expand this data, and we are going to use this preview tab to actually preview the data. GSOD 1929. So this is the data. We can see the preview and moving ahead. Okay, so let's do some queries. So I'm going to go to GSOD 2014 because I have some ambition in mind. Uh, so this I can see I will just query in split tab. So I can select whatever I want. Okay. So I can select star. I can as we saw in the preview, we can see we have STM, WBAN, year, month, date, temperature, count temp. So we can select any data. So let's select SLP from this data and just limit it to 10 because I just want to show you guys. Select, okay, we have to make it relational. Uh, I hope so. I'm doing it right. First, let me run it. I don't think there's something wrong in it. Video means no. I mean it's okay. Cool. So as we can see this, so I already have some queries pasted below. So I'm going to explain this. Select STN. We are going to select STN. Where is this STN? I think it went this side. And also we are going to have timestamp by this side. Year, month, date as timestamp. Replace numerical null value with actual null. So if there is something null, because this is SQL, right? If there is null, we are going to see average of, first we are trying to find average. So what we are doing is, if temperature is 999.9 or null temperature, uh, okay, so we will take the average and we will set it as temperature. Then again we will check the average for WDSP, which is wind speed, and wind speed should be also not equal to this or null. And then we will cast float 64 as wind speed. Then after running the whole query, we will be able to run it. So this is our condition where we are casting year should be greater than 2010, month should be greater than 6, and date should be greater than 12. Okay. So this is going to run in all these data sets. As we can see in this, we have lots and lots of data. 4115582 number of columns. These are the number of columns where we have the data. And more than this data, we have so many years data. These are the number of columns in 1 year, and we have so many years. In this, we are going to check for if year is greater than 2010, like 12 June 2010. So after this, we are going to run it. So let us run this query and wait for it. Okay, so we are able to run this query successfully. Like this was just for exploration. Now we are going to run another query once again, and but this time this is to get the citizens complaint data. So we can see that inside this there was the first column which was 311. Sorry, it went so much below. Uh, says no RG. So this one was the query. This one was the weather database. Now we are going to search for service complaints. So suppose you know what happens in the country is, if someone is in danger, they call 311, which is emergency, and they take their request. They try to send some help if there is some mishappening at their place. So San Francisco, we are trying to check it alphabetically. You can also search directly. Like let's search directly. It is service New York service request. So let's go with New York because that is our that is our task to go with. So we can see the data, STN, WBAN, year, month, day, temperature, count, and all. So this was the thing that this were the service request on this date. So we are going to, sorry, this is JSON data. That is what I was confused with. So I will take this service request. I will tab it here. I don't know. Uh, wait, let's tab it in this. So I open the service request. we can see the schema of the database. This is created date, close date, agency, and also sometimes they have this description so that it is easy to understand. So we have all the data of New York citizens. So as we can see this is the New York citizens. This is someone's address, 890 West 36th Street, and the mobile. This was the resolution. Like someone might have called and they have told that this could the mobile outreach response team went to location but could not find the individual that you reported. It was in Manhattan City. And okay, so let's move ahead to the query part. I'm going to open it in Split tab, and I already have my query, so I'm pasting it and I'm running it. Now I will go ahead with uh, this. We were able to see this. Our We are checking the number of complaints and by complaint type. So suppose there is a noise in residential. So in 2020 there were 4 lakh 7,093 complaints. Some complaint for illegal parking, some complaint for hot water, some for noise, some for heating, hot water, illegal parking, as we can see year by year. So if we see the latest is 2021, I think we can sort it by year. So no, it is not getting sorted directly. Anyways, let's move ahead with the next one. Now we are going to, okay, so again we are going to add data. Maybe don't need to add data. We need to, mm, let me refer what is the next step. Mm, okay, so in this view, I can say this view option is there. So I'm going to select my uh, create data set and going to select it to uh, I'm going to set its name to demos. So let's go ahead with it. So create data set. So I need to set it to demos. Data location I can select basically any data location, but let us leave this to default. Yeah, okay. Mm, cool. Our demos has been created. So next is, as I told, we are going to compose a new query. This one was created. This one was also successful. So I am going to, so I can open the demos. I need to create queries in the demos. And okay, so I have got this query. I am pasting and running this query, and I will change the query settings. I also need to save this query. So I will go to query settings, and in the query settings, uh, this dialog, I need to set the destination table for the query results. Data set, I think I can select it, and I also need to, we can, like, let's say New York and NYC weather, and okay, let's allow large difference. Save and run. After this, I will have this saved in a. So I will also go again to this query settings, and I will save the destination. This I'm just trying to bring the settings back. Yeah, let's run one another query. So in this uh, query we have, like, this is just a normal other query. Only thing is we have used something new in this query, which is grouped by having total complaints and the description. Okay, I think I'm not able to explain very clearly because I haven't prepared much until this point. But now I can say that I need to show the core count. So that was it. So core is the correlation correlation between the complaints and the data. So the negative means no much complaint, and the more positive it means it has some of the complaints. So to summarize it once again, we were we we were able to run this BigQuery public data, and we were able to add this data set to our explore section within this database, and this BigQuery public data is available for everyone. Anyone can go and take this. Uh, there are several tables in this BigQuery database, and we have GSort, GitHub Nested, GitHub Timeline, Natality, Shakespeare, Trigrams, Wikipedia. Like there are so many things. I proceeded with GSort at first. Then I went ahead with the service complaints for New York City, also for the other details related to the weather correlation between the complaints and the weather. Like there was the thing that I wanted to. So this query is quite complicated, but we wanted to select descriptor sum of complaint count as total complaint count. You can see this. So then it is count of wind speed as data count. So this is the wind speed, which is 384. Mm, okay. Then we are rounding the correlation. CORR function is the correlation function of wind speed and average count, and to three decimal places as core count and core correlation PCT. And from this we are selecting from which table. Like we again have lots of tables, so we are also refining the data to be selected. We are selecting as like PCT, and all this counts from another table where we are from demo.nyc weather. And like this query is much complicated and much in depth. I will explain this query in the next video. So see you guys. Thank you for joining in. Have a great day.